Today we're talking about defining, rewriting, and evaluating rational exponents. So I bet you're asking yourself, what's a rational exponent? Well, before we get to that, there's some vocabulary that you need to go back and remember. Most of these you'll know, so only write down the ones that you're absolutely uncertain of. First of all, the exponent, remember, is the number showing how many times you multiply something by itself. Then we have an integer, which are numbers that are not fractions or decimals. They are the positive and negative whole numbers. A rational number, if you remember, is a number that can be written as a fraction. So like 0.25 can be written as 1/4, so it's rational. 0.3 on forever can be written as 1/3, so it's rational. Whole numbers are rational too. A 7 can be written as 7/1, so they're rational. Irrational numbers are the opposite of rational. They're numbers that cannot be written as a fraction. So numbers that are irrational are non-repeating, never-ending decimals, like pi or the square root of 2. A base is the number being raised to an exponent. So if I have x squared, x is my base because that's what has an exponent attached to it. An exponential equation or expression is simply an equation or expression that has an exponent in it. A root is the opposite or inverse of a power and exponent. So a root of a number is the number that when multiplied by itself a certain number of times equals x. So for instance, if I take 4 and I square it to get 16, the square root takes me back to 4. So square root is the opposite or inverse of a power of 2. They kind of undo each other, just like addition and subtraction do. And finally, a radical expression. Radical means root. So a radical expression is simply an expression containing a root. The example I've given you right here is a fifth root. This is the fifth root of 9. You usually work with square roots. So now, you guys know quite a bit about exponents. We're going to expand your knowledge one step further today and talk about rational exponents. Those are exponents that are fractions. So for instance, I have just a general look for a rational exponent. I have a to the m over n power. A, m, and n today all have to be integers, so they're all positive or negative whole numbers. A is called the base. That's the number that's getting taken to the power. M is actually the power, and n represents a root. So when I say a to the m over n power, I'm actually taking the base to the power and then taking the nth root. So let me show you what that looks like. Written as a radical expression, I have the nth root of a to the m power. I also can take the m to the outside of the whole thing by putting the nth root of a in parentheses. But the first one is the way you'll see it most often. So here's a quick example using actual numbers. I have 8 to the 1/3 power. Remember, 8 is the base and it's getting taken to the first power. And then I want to take the third root. So I would say this, the third root or cubed root of 8 to the first power. If I want to evaluate this, it's pretty simple. It means that I'm taking 8 to the first power, then I want to find a number whose third power is 8. Hopefully you've done that enough to know that 2 to the third power is 8. So this whole thing equals 2. The main roots you've worked with in the past have been square roots. So let me show you, using this rational exponent rule, what square roots actually look like as an exponent. So I have the square root of 16. A square root is otherwise known as the second root. So all this time you've been doing square roots, you've actually been doing second roots. I'm going to put the first power on 16. So I'm going to say 16 to the first power, since that's the same as just saying 16. If I change this into my rational exponent look, this is 16 to the 1/2 power. I bet you didn't know that square roots and 1/2 power are exactly the same thing. They both equal 4. So that means I can change my whole square root chart so that they have powers of 1/2 instead. 49 to the 1/2 power will always be 7, and so on. So at first, we're just going to rewrite our rational exponents into a radical expression. In other words, using roots and powers. So 3 to the 6/5 power is the same as 3 to the 6th power, and taking the 5th root. The 5th root of 3 to the 6th power. Those are exactly the same expression. Next, we need to be able to go the other way. We need to be able to take an 8th root of a to the c power and write it using a rational exponent. Remember, a to the power over the root. Some parts of this assignment, you're going to need to remember your exponential properties. So for instance, if I have a base to a power and the whole thing is taken to another power, if you remember what we do with that, we actually multiply the powers. Multiplying fractions, remember we go straight across the top and straight across the bottom. And then I'm going to take the time to reduce that fraction. Notice that it doesn't say just to rewrite it though, it says to evaluate. Evaluate means something different, right? It means let's put this into the calculator and let's find ourselves something that we can round to the nearest thousandth. So to put rational exponents into calculators, it's pretty much the same on every calculator. First of all, you're going to put in the base, which was our 3. Then I'm going to hit my exponent key. Now when my exponents are fractions, I want to use the parentheses. I'm going to put open parenthesis, 2 divided by 3 for my fraction, close parenthesis, and enter. Notice that 2/3 is less than 1, so taking a number to a 2/3 power will actually be less than the original number. If I want to round this to the nearest thousandth, I get 2.080. So that's my evaluation, 2.080. We'll do that again in just a second. So now it's going to ask us to evaluate the exponential expression. The easiest way to do that is to change it into a rational exponent. So we're going to change this into 4 to the 10/8th power. This time I won't really worry about reducing my fraction. I'm just going to put it into the calculator as is. So I'm going to put in 4 exponent, open parenthesis so that I can put in my fraction of 10 over 8, close parenthesis, and enter. And if I need to round this to the nearest thousandth, I'm going to get 5.657. Don't forget to round. 5.657 would be my evaluation. Notice that 10 over 8 is larger than 1, so it actually makes my number bigger. Alright, we're going to go through a little more in class, but for now, I think that's enough. So make sure that you've written down the examples, bring your notebook to class, write down any questions that you have so that you can remember them later, and I hope you have a great day. I'll see you next time.